Have you ever wondered how Siri understands you?
My name is Deepshika, and I'm here to show you how your phone analyzes the words you say using the Fast Fourier Transform.
So what exactly is the Fourier transform? Mathematicians will say it's this, but engineers will call it one of the most widely applicable mathematical discoveries ever. For now, let's think of Fast Fourier Transform, aka FFT, as a machine. If we give cake to the FFT machine, the machine will pop out the cake recipe, including all of its ingredients and their amounts, like flour, eggs, and sugar. How does it do this? FFT actually filters out every single ingredient individually.
This comes with two catches. One is that the filters must be independent, meaning the addition of one ingredient should not affect the results of another filter. The second catch is that all ingredient filters must be present. If not, we can never get the full recipe. Unfortunately for us, FFT does not actually decompose food. Instead, it decomposes signals.
In the case of FFT, signals are anything that take a circular path over time, in other words, a wave. The reason why FFT is so widely applicable is that it can decompose almost any type of wave, from sound waves to the vibrations produced by earthquakes, to radio waves, to even the storage of computer data on a hard disk. However, despite the wide variety of waves, every wave has properties that define it, like amplitude, wavelength, and frequency, which describes how fast each cycle of a wave is completed. FFT normally uses frequencies as filters for signals. Just as we had a flour filter for the cake, FFT would use a 20 Hz filter for a sound wave.
Let's go back to Siri and look at the sound waves that are produced when we talk. A single sound wave is rarely ever just one pure note.
It is often made up of multiple waves of different frequencies that add on to each other to produce irregular waves like this one. When we put the sound wave through FFT, it figures out what waves make up the final product, basically creating a recipe of waves. The output of FFT looks something like this, with super tall peaks at the wave frequencies that are the most powerful in the overall sound wave.
But why would this help? What would we do with a bunch of waves? Well, individual waves are a lot easier to analyze than an entire sound wave, especially when it comes to speech detection.
Siri has a database of commonly used words, but they are only identified by the peaks of the FFT outputs. Each output therefore has an associated meaning with it that is programmed into your phone. When you speak, Siri processes each word with FFT and matches it to a word in its database. Then, it translates those FFT peaks into an action that can be taken by your phone.
So now, whenever you ask Siri silly questions, "Hey Siri, what's 10 to the 200th power?"
Looking. The answer is 100000000.
You'll know exactly what's happening.